Okay, so now we will continue from where we left in the previous video. We ended it on bag of visual words, where I talked about reducing the dimensionality of 128 dimensional shift feature into, let's say, a one bar. Okay, it was like very loose definition of what we do in place recognition using bag of words. So we will continue from there. For example, you had the data set, you had 100 images, you extracted different features, let's say shift. What you did is you obviously every shift feature was 128 dimensional, so you plotted the feature in 128 dimensional space. Don't consider this as a two-dimensional space. This was what I was talking about, where obviously to plot shift feature, obviously you need 128 dimensional space. But here obviously we have 2D space on the board. Imagine as if this is not 2D. In fact, this is 128 dimensional space, and you have plotted all the features that you got from your data set, and you plotted it here. The next thing you do is you cluster it up using k-mean. You plotted different like all the features here, and then you applied k-mean so that it is split up into different clusters. So after the splitting, for example, you got these 4 clusters. After that, you number the cluster. For example, this is number 1, this is number 2, this is number 3, number 4. Now, every descriptor, every feature that is in this cluster is named as 1. So this is why we say that we reduced that 128 dimensional vector into one number, that is 1. Like this 128, not only one 128 dimensional descriptor, in fact every descriptor that falls in this region is represented by this number, which is 1. Okay, and this is why we say that we reduced the dimension. Okay, in fact it is not reduced, it is just allotted another number that is representing the same set of features. Now this cluster is called bag of words. Okay. Now you did this. Now how is information stored in bag of words? For example, you made these 4 clusters. You will make a list of clusters. For example, you have 4 clusters, so you will make a list containing 4 numbers, and every member in this list is pointing to another list. Okay, which is the list of all the images that contain the features that were present in side cluster number 1. Again, in cluster number 1 there were many features, and all the features were not from single image, these were from multiple images, and all the images that contained the features included in cluster 1 are placed here. Okay, the image identifiers of the those images are placed here. So for example, if we have, let's say, 10 images, then image number 1, 3, 5, 7, 9 and 10, these images, the features of these images came under cluster number 1. Okay, and this is how you store the information. Similarly, the cluster number 2 contains the features that were extracted from 2, 4, 6 and 6. Obviously there can be different features in same image. Okay, so if you extracted, let's say, 3 features from same image, let's say image number 6, and all these features fell in, let's say, cluster number 2, then you will include that image identifier multiple times. Okay, so it will be a multi-set. Multi-set, or the list that in which the number repeats, is called a multi-set. So here is a list and which contains image identifiers. So here these are the images in which falls under cluster number 2, and same goes for everyone. This is how you arrange your database. Now, let's say now you have a query image and you want to see if the query image is already present in your database or not. Okay, you have to find the most similar image to your query image. What you will do is you will first find all the features from the query image. Okay, let's say you were dealing with Swift. You found all the Swift from your query image. Now, what you will do is, let's say you found 10 features, okay, and you will plot. Okay, you found 10 features, 10 Swift features. And now what you will do is you will try to plot these 10 features, or you will try to find these features in this database. Now, for example, among these 10 features, first feature fell in cluster number 1. First feature fell in cluster number 1. So, you will come to this cluster and you will find, so this image could be 1, 3, 5, 7, 9 and 10. Okay, this can be any image from these images. Why? Because these images also had the same type of feature that was present in your query image. Okay, now you will make a voting array that will include all the images in the dataset. If you had 200 images, this will be a vector containing image identifiers of 200 images. Now what you will do is, your first descriptor in the query image matched with 1, 3, 5, 7, 9 and 10 number picture. You will increase, you will like set a count variable and you will increase your count. You will initialize this array with 0, 0, 0, 0, 0. It means that right now no image was found similar to your query image, but after checking the first feature, it was found similar with 1, 3, 5, 7, 9 and 10. So at number 1 you will add plus 1, at number 3 you will add plus 1, at number 5 you will add plus 1, at number 7 you will add plus 1. Similarly, every image that was present in this cluster, you will increase its number. Now you found 10 features in the query image, right? Now let's say the remaining let's say 3 more descriptors among these 10 fell under cluster number 2. Okay, so what you will do is you will come to cluster number 2 and you will increase again the count of your voting array to plus 1. So it is image number 2 plus 1, image number 4 plus 1, image number 6 is coming 2 times, so plus 1 plus 1, image number 7 plus 1, image number 6 again plus 1. Okay, now the obviously many members of this array will be 0, many will be obviously at some integer value, and obviously the maximum of this number will indicate that that particular image is most similar with your query image. Similarly, again another, you found 3 features that correspond to cluster number 2. So you will do this 3 times and then again plus 1 plus 1, and 6 was repeating 3 times, so you will increase it to 3 times. Okay, so you are seeing figure number 6 is getting more votes, or image number 6 is getting more votes. So that is how you retrieve your image. Okay, that is how you find that the image, your query image, is most similar with image number 6 of your dataset. But again, here you are not having any spatial information. So it could be possible that it is not exactly equal to the query image, but it is just similar. And for similar image, I gave an example in last video that if this is one image and this is another image, it could be possible that this image is like this and this image is like this. Now there can be two like entirely different pictures, but the data set, the features just matched. So obviously you will find different. You will take top, let's say top 5 most similar images, and then you will apply any spatial similarity between your query image and your 5 most similar image. You will find any spatial features that may match with your query image and the most k similar images in your data set. Obviously you can find, let's say, essential matrix and F matrix, and then you can like do ransack between two like pair of images, and with the most similar obviously that the pair that will get most number of similar features via ransack will be the most similar picture with your query image. So this is how bag of words work. Okay, in the next video we will see how we can make vocabulary tree out of it to make this retrieval process even faster. Thank you.